Welcome back. This is lesson number 4 in complex numbers. In this lesson, we will learn about complex number interpretation in different forms. So, we will first learn about this rectangular interpretation. That's number 1 there. Now, rectangular interpretation is what we have already done. That is, if we take a complex number which is equal to, shall we say, just 2 plus j3, or in the general form, say just z is equal to x plus jy. So, where the real part and the imaginary part, we call this the rectangular interpretation. So, in rectangular interpretation, we show the real part separately and the imaginary part separately, and that will be a real number, and this j signifies that's a imaginary number. So, in the Argan diagram, we can show it like we used to do earlier. That's negative g-axis, positive g-axis, real axis, and the negative real axis. So, this, if we just have our scale like this, so that's 0, 1, 2, 3, 4 like that, and then on this side also 0, 1, 2, 3 like that, and then 2 plus j3, 2, that is on the x-axis or the real axis, and j3, that is there. So, your number will be somewhere there, that's your complex number, and we say that's the representation in rectangular form. So, we are quite clear about that one. So, next let's go on to this polar representation of a complex number, which also we have done, but we have not really defined it. We have our basic knowledge now to understand what this polar interpretation. So, if you take this same complex number again, 2 plus j3, the polar representation is, if we can show this complex number by this phasor or vector and by its magnitude and the angle. We know the magnitude is actually the modulus of this complex number, and the angle is the argument of this complex number. So, in the polar form, we can say this complex number can be represented as z and angle theta. So, this is the complex number z, and that's the modulus, and that's the argument. So, in this particular example, so earlier we found that the argument, the modulus is, we can find it again, right? Z is equal to square root of 2 squared plus 3 squared, which is square root of 13, which we found earlier as 3 point something. So, let's just check that again. So, 13 square root is 3.60, that's 3.60, and then the angle we will find now. So, tan theta is equal to 3 over 2, and theta is equal to tan inverse, that's equal to 1.5, tan inverse 1.5. So let's find what is tan inverse 1.5 is. So that's 1.5 shift tan, so that gives 56.3 degrees. So theta is equal to 56.3 degrees. So how we represent this same vector now in polar form is that z is equal to 3.6 angle 56.3. So this is the rectangular interpretation of this complex number. Now the same number we can interpret in a different way. That's the polar representation of the same complex number. Next, we will define what is the trigonometric interpretation. So trigonometric interpretation. So in trigonometric interpretation, which is similar to this polar form, which is a sort of a breakaway from the polar form. So in the this complex number, which we took as 2 plus j3, we know the polar form is 3.6 angle 56.3. So in other words, it's telling us that this is a vector which is 3.6 in magnitude and which has an angle 56.3 degrees with the real axis. So we can actually find the real part, that's the real axis. We can find the real part and the imaginary part using this. So here we use our trigonometric knowledge. Now this real part, right, real part, if you say that is equal to x, x is equal to 3.6 cos 56.3, and the imaginary part, that is this, will be 3.6 sine 56.3. So that is 3.6 sine 56.3. So in general, now in this case, we know if you simplify, we will get here 2 and we will get here 3. If you want, I can show you that by this, right? Now 56.3 cos is that much, and when you multiply by 3.6, you will get 1.99, that's almost 2 there. And if you take 56.3 sine, that's that much, and if you multiply that by 3.6, you will get 2.99, that is almost 3 there. So in general, if we have a complex number, say if we have a complex number in polar form, say z is equal to shall we say r theta, where r is the modulus and theta is the angle. We can represent that in the trigonometric form. Z is equal to r cos theta plus j sin theta, right? R, we have to, R is common to both, so that's how we represent in trigonometric form. So in other words, this is same as a r cos theta plus r j sin theta, which will give you the same result. So this is the trigonometric form of representing this complex number. So we can do some examples in the next lesson. Thank you.